I made a service, a website, which I think is kind of fun. It takes someone's face and it replaces it with an emoji. Quite a straightforward and simple thing from a user's point of view, quite complex if you think about it from a machine learning and artificial intelligence point of view. But in this video, I'm going to show you exactly how I put it together and show you the source code so that you can go and put it together yourself. Maybe you can extend on this, break it, fix it, learn something from it. So just to cover how it works, it's called Emoji Me and it's hosted at this link, which I'm going to have listed here and is also in the comments below. And all you have to do is go to browse, find a photograph on your local machine, and upload. Here is one of me and Derek and Wendy and Peter at the summit, the AWS summit, a couple of weeks ago, and it replaces all of the faces with emojis. So how does this work? Well, behind the scenes, it's using AWS Rekognition. Rekognition is a service which is used for object detection inside of images. It's a pre-trained model. Let's jump into the AWS console and I'll show it you in action because like many of the AWS AI services, this actually has a really cool demo in the console so that you can see exactly how it works. So let's go to try demo. And the first thing that it brings up is this image of someone skateboarding in the middle of the street. And you can see that it's recognized cars and the person and a skateboard and things inside of that image. Over on the left-hand side, you can actually see there are different modes in which Rekognition can run. And one of them is facial analysis. And in this mode, it will find faces in the image. It won't necessarily tell you, well, it won't tell you who they are, but it will tell you that it's found a face and attributes to do with that face. And with the demo online, you can actually go and upload the image that you want to play around with. So if I just go and put the same image in, I think this is the same image. Yes, it is. It will upload it into the service. It basically does exactly what my app does in a way, but now it actually finds those faces and gives us the details of those. Now, all of these services, the AI services from AWS, they are something that you can integrate with an API call, a simple API call using the SDK of your language of choice. And over on the right-hand side here, if we just scroll down, you can see the request object, which is right here. It's just a very simple structure. Basically, pass in the data, the bytes of the image itself, and tell them what attributes you want. So in this particular case, it's saying all. Give me all the attributes that you can find. Everything that the model's been trained to discover. And then if you look down here in the response, you can see the structure of the response. So it brings back a list of all the faces it can find, and then it has bounding boxes. So you've got the width and the height and the top and the left so that you can actually find the location, the actual coordinate, the pixel values ultimately of where the faces are. If we look down here as well, there are other things. There are things like emotions. Now, this emoji replacement service that I've put together will actually use this emotion value and place the appropriate, I think the appropriate emoji over the face of that person. And we'll see that in action in just a moment. So we've got the emotions coming out there with some confidence scores. It's got landmarks so you can see whereabouts the eyes and the nose and the mouth are and the different aspects of that. And then right down underneath that, we have pose. So we have the roll, the yaw and the pitch of the face. And so that helps me in the code that I've written to make sure that the emoji is exactly aligned up with the face. If I just go back to Emoji Me, let's just upload one other picture. This is also from the AWS Summit in Sydney. So it's myself and Brooke. And you can see that we've all got different expressions. And you can see also that there's a slight tilt on my head and the emoji is mapped exactly over the top of the face. So that's what the code's going to do. Let me show you how you can put this together yourself in your own account. I'm going to redeploy this into a slightly different URL and show you and make some changes to it. If you scroll down on this page, again, the link to this is below, then you'll find some links on this page, which link to the lambda function, which is behind all of this. So it's using an AWS lambda function, the website source as well in 2 zip files. And I've downloaded those already. And so let's go and take a look at those. So here I am inside of Visual Studio Code, and I can't open up the zip files in Visual Studio Code. So let me just expand them out in Finder. And here they are. And there are my folders expanded out. So for the website itself, it's really quite straightforward. it's just one page, one HTML file. There are a couple of images in there as well, but it's just one HTML file. Right at the very top, there is a script section here where we put in a URL, and this is the URL for the Lambda function that we're going to call, but we haven't made that yet, so we can't put that in quite yet. And then if you just look through here, it brings in from CDNs elsewhere things like Bootstrap and things like the jQuery and libraries like that. But everything else is embedded in here. Simple piece of code. There's some JavaScript down here which is responsible for taking the image and passing it to that URL endpoint. One thing it does do is it does do some resizing of the image before it sends it, so it will resize it down to 600 by 600 or 600 maximum dimensions, just so that we're not sending vast quantities of data around. And it sends it up to the endpoint. It does that through this AJAX call here, and so it's going to post it to the URL with a content type of JSON. Okay, so that's how that web page works. Super, super simple, really just there to test all of the capability that we put together in the Lambda function itself. So let's have a look at the Lambda function here. So you can see we've got the two things here. We've got the Lambda function itself, the Python, and then we've got an images folder. Inside of the images folder, we've got all of the different emojis that we're going to upload. So we're going to upload all of these into a Lambda function. So the Lambda function has access to the images, and it also has access, of course, to the code. Let's take a look at the code, and here it is. It's fairly straightforward, and you'll see some things in here which are aligned to the Rekognition console page that we looked at just a moment ago. So basically what happens here is that the image gets passed into the Lambda function through the event object, and it's basically the entire body of the event that's passed through from this website. The first thing that we do is we take it and we decode it from base 64, which is the way it gets passed up. We then take it and we also do another crunching of the image down to maximum of 600 pixels. It's possible that someone might hit this URL without using the HTML first, or they might hack around with the HTML. And I just want to make sure that we're truncating this image down a bit. Truncating is probably not quite the right word. We're sizing the image down a bit, resizing it smaller, so that we're not having to deal with a whole bunch of data that we don't really need to for an application like this. So we grab that, we've got the image now, we've resized it down, and then we basically send it off to the Rekognition service. So I'm using Python here, you've probably noticed. I'm using the Boto 3 library, which is the SDK for communicating with AWS, and we use that to create a Rekognition client. Rekognition with a K, by the way. As we see this throughout this, it's not misspelt, it is Rekognition with a K. And then we get the responses back from that client by calling detect faces and passing in that structure that we looked at just a moment ago. So we pass in all of the bytes of the image, and then we ask for the attributes. We ask for all of the attributes it can find. Then with the response that we get back from that, and if you remember what that looked like, it had a list of basically all of the faces, and then inside all of those faces it had the different attributes of those faces. So we then loop through the response that we get for each face, and the first thing that we need to do is we need to figure out exactly where in the image the faces are. So the values we get back are from 0 to 1, 0 being all the way on the left hand side, for example, and then 1 being all the way over on the right hand side. So we need to multiply that value by the number of pixels in the image so that we can have a pixel representation of where the face is. And so that's what I do in this section here, both in the X and the Y axis. We find out the exact pixel location of the top left and the width and the height of the actual face. We then also grab from that data the roll pose value so that we can make sure that we get the face angled correctly. We then pull out the emotion. So we basically pick the top emotion that's come out from the list of all of the emotions, because it's the top emotion that the model had the most confidence about. So we're going to say that's what it is. And we get that back as a string value, and we use that string value to open up one of the images that we've uploaded with our Lambda function, which is over on the side here. With that image then that we've opened up, that emoji image, we resize it to the size of the person's face. We then rotate it to the role of the person's face, and then we use paste to go and paste that over the top of the image. Now, all of that image manipulation stuff that we're doing, both the resizing of the image in the first place and then the resizing of the emoji and pasting it over the top, to do that, we're using a library called the Python image library, PIL, or otherwise known as Pillow. So we need that library in here to be able to do all of that heavy lifting of the graphics work, if you like. So this Lambda function does two main things. I guess it coordinates everything, but it sends the data, the image itself, off to Rekognition. Rekognition then does the heavy lifting of the machine learning of finding the faces and getting all those attributes. But that's all it does. It just provides that structure back. Then the Lambda function is the thing that does the actual graphic manipulation to actually compile the output that we want to see from the information that we got from Rekognition. So once it's done all of that, and once it's done that for each face that it's found in the image, and it can loop through as many faces as are found, we'll then do another base64 encoding of the image, and we'll send it back to the user, or we'll send it back to the website that made the call in the first place. That's how the Lambda function works. All right, let's get into the AWS console and upload this and make this work. So I'm just going to jump over to Lambda, and you can see I've already got an Emoji Me function in here. This is the one that's actually currently live on the website. What I'm now going to do is I'm going to redeploy it and do it again so you can see the steps involved to take the zip file from that download on the website and create your own version. So I'm going to say create function. I'm going to say Emoji Me YouTube demo, because that's a pretty boring name, but it says exactly what we're doing. In terms of runtime, I'm going to go down and choose a Python runtime. Now, we're not choosing Python 3.9. We're going to choose Python 3.8, which is just down here. There's a specific reason for doing that, and we'll talk more about that in a moment, but it's the library, the Pillow library that we're using for the image manipulation. The particular one we're going to use is Python 3.8. Then I'm going to roll down and scroll down to the bottom and say create function. We're going to leave everything else as default. For now, there are some changes that we're going to make, but we can make that once the function's actually being created. So with that pressed, AWS is going away and creating the shell of our Lambda function for us, and it's going to come back with generic function handler in there, so generic code. What we need to do is we need to upload that zip file that we downloaded. So I exploded out the zip file or expanded out the zip file so that we could take a look at it, but we actually need to upload the zip file in so that we get all of the images as well as the Lambda function code itself. So if I just scroll down here and go upload from zip file, and then say we've got an existing zip file and it's smaller than 10 meg, so I can go upload, and I go to where I have those stored for the moment. I have my Lambda zip. I'm going to press open and save. It will now upload that. It's super small, so it uploads really quickly. And so all of that code that we were just looking at is now inside of Lambda, and we have all of the images inside of here as well. I showed you this code and the images over in Visual Studio Code because the console here doesn't have the ability to show those images to us at the moment. So that's the code there. That's what we needed. You actually don't need to change anything about this because it sort of works quite independently. But there are some things that we need to do to the Lambda function in order for this to be able to work. And one of the first things that we need to be able to do is we need to give it permission to call the Rekognition service on our behalf. So at the moment, it's got a generic role that was created by the console when we created the Lambda function, and we need to give it permissions to do more than what it can currently do. So if I scroll to configuration, and then I go down to permissions on the left-hand side here, you can see here that the only permissions it has are to CloudWatch logs. So a very generic Lambda function. It has the ability to spit out logs into CloudWatch so that we can debug and stuff. It's very useful, but we need to give it more than that. So I'm going to click on the role here, and it will open up this role inside of Identity and Access Management so that we can go ahead and change that or add more permissions to it. And we're going to add a fairly broad set of permissions to Rekognition. And this isn't necessarily something that I would recommend, and definitely don't recommend doing in production. But for now, for what we're doing, it's fine. We're just going to add all access into Rekognition. So here's the role for this particular Lambda function. And if we go over to the side here and say add permissions, attach policies, then we get a list of all of the policies that are available in this account, of which pretty much they're all managed policies from AWS. So if I type in REK for my search filter, I get down to the 4 managed policies, which are all in relation to Rekognition. And I'm going to tick at the side here for Amazon Rekognition full access. So this will give it more access to Rekognition than we really require, but it's fairly safe to do so. I would recommend, if you're going to do any kind of production deployment here, scope down these permissions to exactly just the function calls that you need from that particular service. So let's say attach policies, and it says, congratulations, they're attached. That's fantastic. Let's go back to our Lambda function. And what I'm going to do here, I'm just going to refresh the page. And I want to refresh the page just to show us that when we go back down here again to the resource summary, I think it is, where it's can see what permissions it has. We do that drop down, and now we've got both Rekognition and CloudWatch logs in there so that we know we've got the right thing. Now, whilst I'm in this this configuration, let's go to general configuration, because the next thing that we need to change is the timeout of the Lambda function itself. At the moment, the Lambda function will time out after 3 seconds. And if you manage to do that with the Lambda function, it's good. If you can get a Lambda function to return sub-second, that's kind of what you want. With this, though, because it is making an external service call to Rekognition, it's also passing that binary data there and then getting all that data back. It may well take longer than 3 seconds. So let's go to edit, and I'm just going to put this up to 1 minute. It won't take 1 minute, but that's plenty of time for the service to respond. So let's click save on that. It's not going to charge us for 1 minute each time. It just means that if we get to 1 minute and it still hasn't worked, then something's gone wrong and it's just going to shut the function down. Okay, so with all of those things, we're nearly ready to call this function. There's just a couple more things that we need to do. Now, you'll notice from the actual code itself that one of the things at the top here is that we import the PIL library, the Python image library, also known as Pillow. And by doing that, we're basically asking the environment to load in that library, but that library doesn't exist inside of Lambda. And if I was to run this, we'd get an error message saying that it can't find it. JSON, Boto3 and Base64 are all generic enough that they already exist inside of the Lambda environment, as does IO, but this one does not. So we need to load this one in. Now, one way you can do that is you can, in your local development environment, when you're working on the code, you could actually install the Pillow library. And then when you put the zip file together, make sure that you zip up that library along with the rest of your code and upload it. That's totally doable. An easier way, potentially, especially when you're doing stuff like this, is to load in a Lambda layer. Now, the Lambda layer is an external library of code that you can bring in and you can share across many different functions that you might have in your account. In fact, you can also create layers and share them with other people. And that's exactly what I'm going to do here. It's not my layer that I'm going to share with you. I'm going to use a layer that someone else has already made and shared out with the community. So if I go into this tab here, we get to see KLayers. I'll have a link to this in the description below, and this is actually something that you need to specifically find the layer which works for you. Basically, what KLayers has done is it's collected together a whole bunch of different layers that people have made for Python 3.8 in this particular case, for this particular page, for all kinds of different things, requests and Pillow libraries and encryption libraries and all kinds of stuff, things that you can just easily add into your own Lambda function. Now, whether you want to do this again in production, because it is technically someone else's code that they're putting together, you don't really know what's in there, you can check it out, it's all open source, but you may also just want to do your own and handle your own if you're in a production environment. But for me and for what I'm doing here, and I've also tested it, it works fine, I'm quite happy to use this. So I need to scroll down and find my particular region from this repo that's been put together. and I'm working out of the Sydney region. You will need to go and choose your own region because the lambda layer needs to be in the same region as your lambda function. I'm currently doing all of this in Sydney. I think I am anyway. Let's go and double check. Yeah, I'm doing it in Sydney region, which is my home region, if you like. All right, let's go back and open up my list, which is the Sydney list. And then throughout all of this, I need to find the particular one I'm looking for, which is pillow. And there it is. So I've just done a Control F to find pillow. And what I'm looking for is this value here. So it tells me it's pillow. It tells me the version of the pillow library. And then the ARN for the actual layer is right here. So I'm going to copy that and I'm going to paste it into the Lambda console. So let's go back to Lambda, and where we go is we're just going to scroll up and we've got this link to layers just underneath where it has my function name. And if I click that, I think what it actually does is scroll down towards the bottom of the page where we've now got this layers section. So I'm going to say add a layer. And I'm going to say that I have a specific ARN. So you can choose layers that you've already got and you've already created inside of your own account if you've got any. I'm just going to say, I have found this layer externally. I want to go and use this one. So I paste in the ARN. I can click verify so that it can go off and find it and say, okay, well, this is what I found. This is what the description is with the hash value for it. It also tells us about the compatible runtimes. And you'll notice here it does actually say 3.9, but the specific aspects of what I'm looking for out of the pillow library don't seem to work for me in 3.9. So works in 3.8. That's why we chose 3.8 when we created this Lambda function in the first place. So I'm happy with that. So let's click add. And once we've done that, technically the Lambda function should work. We should be able to throw data at it and we should be able to look to see what the output's like. At the very least, we should look in CloudWatch logs to see the evidence of the fact that it's run. But the only thing right now is we don't have any way to call it. So this Lambda function sits inside of my AWS account and it's kind of isolated inside of there. I can execute it with IAM credentials within the account. But what I want to have happen is someone external, when they're looking at a site like Emoji Me, to be able to send the image from their browser directly to this function. Now, in the past, what I would have done is use the API gateway. The API gateway is a service which can basically have an external API endpoint, which you can then map to whatever resources you want internally inside of your AWS account. But recently, AWS have released a new feature on Lambda itself, which means that you don't have to use the API gateway. You may still want to for various scenarios, but in simple ones, such as this, you don't need to. So if I scroll down here and go to configuration and scroll down on the left-hand side here, I get to function URL. And so function URL basically sets up a mini API gateway just for this Lambda function. And it's just going to receive the request straight in and just map it straight back out again. Super simple, very few configuration parameters here, but there are some. So let's go and say create function URL. And the first thing that we have to look at is the authentication type. Now, it is recommended to put authentication on your function URL. If you're doing this in any kind of production capacity, or if you're putting this into an application that you have, you really want to think about how you can manage the calls to this URL endpoint, because without any authentication, anybody can call it as often as they want, and they can just smash that endpoint with data. Now, this is a public service that I'm putting together for the public good. Everybody should be able to have an emoji over their face. So I'm going to say none, but I'm saying none, understanding why I'm saying none and sort of accepting the risks, if you like. Then I'm going to scroll down here and say configure cross-origin resource sharing. This is the bane of your life and your existence if you write single page applications that do call out to API endpoints. It's always the thing that you end up sort of having to muck about with to try and make it work exactly as you want. But it's important because what it says is that the server, in this case the URL endpoint, the function URL endpoint, will accept requests when it hasn't come from its own domain. And in this particular case, the JavaScript is going to be running on my Emoji Me domain, or it could be running on your local machine, or it could be running wherever. So we need to make sure that it will accept those requests. So let's click that tick box there. And then we have some options. It's got, first of all, allow origin. Now I'm going to leave that as star. In the actual implementation, I've done this at the actual production deployment, if you can call it that, of Emoji Me. I have actually filled out the domain name that I'm using, but star, which basically means accept any request coming from anywhere, is fine for now. We can then leave expose headers the way it is, but allow headers, we do need to add a value. If you remember when we looked in the function code, which I'll just switch to now and have a look at the website itself, the website does actually send in a content type of JSON. So it does send that in. We need to allow that header to go into our application. So I'm going to say here, content hyphen type. I realize that it's different syntax from the way it is in that JavaScript library, but this is the way it is done for the actual HTTP headers itself, content hyphen type. Then we need to look at allowed methods. So at the moment, optional, basically, that we don't have any allowed methods. We could say just go ahead and allow everything. But again, if we look at the code, it's actually making a post. We're going to post the image in. So we're not using get, we're using post. So I'm going to go ahead here and say post. And so that will allow the particular method that we're looking for. At least it does sort of like constrain it down just a little bit. Then I'm going to scroll down some more. It's going to give me a bit of a summary of what's going on. And then I'm going to click save. And that should create a URL endpoint for our Lambda function. So now we are ready to hit this endpoint and actually give it some data and make it work. So what I'm going to do is I'm just going to copy this function URL here. So I'm just going to copy that just with that handy little icon. I'm going to head back over to my HTML code for the site. I'm going to scroll back up to the top because what I need to do is I need to replace this string here, which says Lambda function URL goes here. And I need to paste in the value that I've just copied. So I'm going to highlight everything between the quote marks, press paste, and now I've got that. If I can just, I'm zooming in so that you hopefully can see it, but at the same time it kind of makes it that I've got to scroll backwards and forwards. So you can see there that the API URL is now set to the value that I've just gotten out of that Lambda console. So let's make sure I save this because that's obviously super important. And then we're done. Now, there's a couple of different ways that you can test this out. One way is you can actually load this HTML into a browser locally on your own machine. But in order for that to be able to work, you do need to have some configuration on that browser to actually ignore cores. That's basically what the function of the plugin that I have says. And the reason for that is because we've got JavaScript running on code locally on my machine, calling out to web services. That's basically just not allowed in browsers because it's seen as a vulnerability potentially that someone might be able to sort of send you some malicious code and get you to click on it. So you either have to turn that off, or what you can do is upload this to an actual web server on the internet somewhere, and then everything should work just fine. So I'm going to do that. So if I go back to my AWS console, I've got an S3 bucket already created. Here it is. This is actually the bucket which I'm using to host the actual website that's currently there. But I've created a subfolder, a folder in that called YouTube demo, which you can see here. And so I should be able to upload my code into here and hit this alternative endpoint, and we'll see it working. In fact, just to make sure that we can see that it is different, let's go into this code here. I'm just going to make some changes to the title. So right up at the top where it says Emoji Me, I'm going to say Emoji Me YouTube demo, just so that you can see that it is a different instance and I'm not just showing you the same thing as I showed you before. All right, so we've got that done there and saved. Make sure you save it. Let's go back to here, and I'm now going to upload the files that we've just had. So I can just have them off screen here. Now the files are let's go back so I can show you quickly. We've got the HTML file. Let's collapse that down. We've got the HTML file itself, and then we've got a couple of different images which are just used just to make it look pretty, I guess. So we'll want to upload those as well, just so that the website doesn't break. So let's go ahead and grab back.png, happy.png, and index.html, and we'll drag them all into there, scroll down and say upload. And they should upload pretty quickly. And this is kind of fingers crossed time, right? This is fingers crossed time that it's going to work. So now I should be able to navigate back to my website. But I'm going to put / what was it? YouTube demo. Is that what it was called? Let's go back. Yes, YouTube. Actually, it's spelt correctly there. And I've noticed I've spelled it incorrectly here. So let me just paste it over there and hit enter. And hopefully, oh, do I have to put in an index.html? Thank goodness, right. So I did have to put the index.html just because of the way that the website's configured at the moment. If you want to know more about how to host websites the right way using S3 and using CloudFront, that's super important, then drop me a comment below because I'd be more than happy to put together a video about how to do all of that. But here we go. We have my new website up. You can see it's a new website because it says YouTube demo in the corner. So now, fingers crossed time, is it actually going to work? Let's go ahead and click browse. Let's upload the image that we had before, why not? Which is me and my Brooke, and Brooke at the summit. And hopefully it should put emojis on here. Hey, it does. And so we can just show that this is actually the Lambda function that we were working on. So if I go back to the Lambda console, so this is our Emoji Me YouTube demo function. If I go down to monitor, and inside of monitor, there is this button to say view logs in CloudWatch. And I'm going to go off to that and do that inside of CloudWatch. Now, this is also what you'd want to do if for some reason it wasn't working for you, then going into CloudWatch and looking at the logs can sometimes be quite helpful. Do you see any logs at all? If you don't, then your endpoint's not being hit. If you do see some outputs, as we're seeing here, then if you navigate into it, you might see an error message in here. But of course, we're not seeing an error message because it worked successfully. So it says it loaded the image, and I've just got some basic log lines in there just so that you can see that it's doing some stuff. There is a temptation in the formation of the Lambda function, if we go back to the code just for 1 second, to basically print out the entire event. Now, if you do that, you'll end up actually printing out a base64 encoded version of the image into your log files. And that's going to take up a whole heap of space, and you probably don't want to do that. I have got here right at the very top an example of just taking the request context from the event, which will log things like the browser that the user was using, the IP address that they were coming from, and bits and pieces like that, just so that you can do some fault finding. But for now, that's commented out. So there you go. That's how to take the source code from the Emoji Me sample that I put together. Again, that's all down here at the bottom in the zip files here. Don't forget to check out these other links too. One of them will take you to YouTube, which you're kind of already looking at, but LinkedIn is there as well. Definitely please do connect with me on LinkedIn because I'd love to talk to you about this kind of stuff. And if you've got any problems and you want some sort of one-on-one help with this, then I'm more than happy to jump into a conversation with you and see if I can help you out. Please do like this video and help me to be able to spread this to everybody else. Also subscribe to this channel as well so that you get to see more videos like this. Thank you so much for watching, and I'll see you next time.